So we know what to do to start this one. We're going to factor these denominators. We can factor a 3 out of here, and we can factor this trinomial. So let's do that. So we're going to get 7 over, let's take that 3 out, and we'll be left with x plus 2 minus 4 over x plus 3 equals, we'll get a 9 over, how about an x and an x? And yet, let's use a 3 and a 2, and we'll make them both positive. That'll give us that 5. So from this factored form, we can get the LCD. We're going to have 3, right? We get that 3 right from here. We'll get that x plus 2. Now that x plus 2 appears here and here, but it's just to the first power, so we need to write it only once. We've got that x plus 3 here and here, but again, it's just to the first power. So we'll just write it once. And we need excluded values, so let's say x cannot equal to negative 2 from here and negative 3 from here. Now that 3 has no effect on the excluded values. What we're looking for was going to make the denominator 0, and this 3 is never going to be 0, so it has no effect on our excluded values. So I'm going to circle that so I can find it later. And now we know what to do here. We're going to write the LCD right next to every one of these terms. So let's do that. So we are going to get this leftmost term, that's 7 over 3 times x plus 2 times the LCD, 3, x plus 2 times x plus 3. Then the minus, that middle term there, 4 over x plus 3 times the LCD, 3, x plus 2, x plus 3, equals that rightmost term, 9 over x plus 3, x plus 2. And we'll multiply that by the LCD, 3, x plus 3, x plus 2. Now, all these denominators are going to cancel, so that 3 will cancel with that 3, that x plus 2 with this x plus 2, and we are left with 7 times that x plus 3. So let's write that. We'll get 7 times that x plus 3. Then we'll get minus, right, that minus right there, and then this x plus 3 is going to cancel with that one, so let's do that cancel. That x plus 3 goes with that x plus 3, and we are left with this 4 times 3 times x plus 2. I'll do the multiplication in the next step, but right now let's just write it. 4 times 3 times x plus 2. And now, on the right side of the equal sign, that x plus 3 goes with that one. That x plus 2 goes with that one, and we're left with 9 times 3. So let's cancel. X plus 3 goes there, x plus 2 goes here, and we're all equal to that 9 times 3. So let's finish this up. Let's expand. So we'll get, multiplying through, we'll get 7x plus 21, right? Distribute that 7. Minus, now this is a 12. 12 times x, 12x. Negative 12 times positive 2 is minus 24 equals 27. And on the right side, you can see we've got 7x's minus 12x's. That'll leave us with negative 5x's. And then we've got 21 minus 24. Well, that's a minus 3 equals 27. Now I'll go up to the top right here. This is adding 3 to both sides. We'll get negative 5x equals, right, we're going to add this 3 to both sides, so that'll give us a 30 over on the right side. And now we're going to divide by negative 5, so that'll give us x equals negative 6. And as we always do, we need to check to see if this is an excluded value. Potential solution right now, so look back here to our LCD and excluded values. We're okay here. The only excluded values were negative 2, because I get a 0 there, and a negative 3, because that produces a 0 here. This negative 6, perfectly good. So let's conclude now that the solution to this equation is negative 6. Let's give this one a try, 77. So let's factor, we know, factor all these denominators here so we can get the LCD. So that'll give us 4 over, how about if we do this, x and x, let's go with a 2 and a 1, right, a 2 and a 1, that's the only way to get a 2. And now that's negative, so I'm going to put the negative here, right? I'll put that negative sign with the bigger of the two products. The way I've written mine, the inner product is 2x, the outer product is only 1x, so the bigger one is this one, and that's going to be that negative. So we'll get negative 2 plus 1 equals, okay, here we've got x plus 22, and it just happens to have the same denominator, which we just factored. So how about x minus 2, x plus 1, minus 18, what are we going to get here? X and x, only one way to get that 3, a 3 and a 1. I think I'm going to make this 3 negative. There's negative 3 plus 1 gives us that negative 2. So we've got it factored, those denominators factored. Let's get the LCD now. So the LCD is, okay, we get x minus 2, x plus 1, and x minus 3. So let's write those. We'll get that x minus 2. Let's do a little better job of writing that 2. X plus 1 and x minus 3. And excluded values, you can see them. X is not equal to 2, negative 1, and 3. Right? The 2 comes from here. Right? If x is 2, 2 minus 2 is 0. The negative 1 comes from here. Change the sign, so we'll get negative 1 plus 1 is 0, and 3 minus 3 is 0. So there's our excluded values and our LCD. So I'll circle it so I can find it at the end. And now I'm going to write this LCD alongside every one of these 3 originals. So this is going to probably take up all of our tablet here. So let's give it a try. We're going to get 4 over x minus 2, x plus 1 times the LCD, x minus 2, x plus 1, x minus 3, equals, that middle term, x plus 22 over x minus 2, x plus 1 times the LCD, x minus 2, x plus 1, x minus 3, and then that minus sign, right, I'm talking about that minus sign right there, this term, 18 over x minus 3, x plus 1 times the LCD. X minus 2, x plus 1, and I'll squeeze it in right here, x minus 3. Okay, now all these denominators are going to cancel, right? This x minus 2 goes with that one. This x plus 1 goes with that one. And then we're left with 4 times that x minus 3. So we're left with 4 times x minus 3 equals, now in this middle term, right, now we're right over here. This x minus 2 will cancel with that one. That x plus 1 with that one. So let's do that. X minus 2 goes. X plus 1 goes. And we are left with this x plus 22. Let's write it here. More than one term, someone use parentheses. X plus 22 times x minus 3. Right, that x plus 22 times that x minus 3. And then, in this last term over here, x minus 3's will go, x plus 1's will go, and we're left with 18 times x minus 2. So let's write what we've got here. This x minus 3 goes with that one. This x plus 1 with that one. And then we're left with this minus 18 times x minus 2. So let's multiply through here. We will get 4x minus 12 equals, now, x squared minus 3x, there's that outer product, plus 22x, we'll do them one at a time here, plus 22x, and then minus 66, right, the outer product, 22 times 3 is that 66, and then, move on, minus 18x plus 36. So let's combine some like terms. We'll get this 4x minus 12 equals, now on this right side we've got an x squared. And then we have, let's count them up. We've got negative 3x's plus 22x's. That's 19x's. But 19x's minus 18x's, that just leaves an x. So we've got a plus x. And then, what have we got here? We've got negative 66 plus 36. That's going to give us a negative 30. So minus 30. Now, this is in a quadratic equation, right? It's quadratic. We've got a squared term, and we know how to solve these. We have a method. We get everything on one side, 0 on the other. Why don't we subtract 4x, add 12, and get a 0 on this side? So let's do that. So if we add 12, we'll get 0 here. Let's write it, 0. If we add 12, we're going to subtract the 4x to get a 0. We'll add 12, so we'll get 0 on that side, equals x squared. Now we're subtracting 4x, right? We subtracted 4x, so x minus 4x minus 3x. And then we're adding 12, so negative 30 plus 12 is negative 18. This is quadratic. Let's see if we can factor this. Now I'm going to factor it all the way up here on the top right. So this is going to look like this. We'll get 0 equals, don't forget the 0 equals. Let's factor. We'll get x, and now the factors of 18, that'll give us a 3. I think we're looking at a 6 and a 3. So let's write that. A 6 and a 3. In fact, I think it's going to be a negative 6 and a plus 3, right? This will give us 3x minus 6x. Down here is at minus 3x. And from here, we can read off the solution. We're going to read off here that x is equal to 6 and negative 3. But as we always do in these rational equations, we're going to check to see that these potential solutions are both good. So let's look back over here to excluded values. Here's what we've excluded. A 2, a negative 1, and a 3. We didn't get any of those. We got a 6 and a 3. So if we did everything right, which I think we did, we can conclude now that the solutions, there's two solutions to this equation. We could get 6 or negative 3.